install the packages as they say to install. So I think actually Dash, or at least Pandas, might come installed by default. But if you go to the package websites, they'll tell you exactly how to install them. It's usually just conda install package name from the conda prompt.
Um, Garrett, just so you know ahead of time, once you start sharing your screen, you're gonna want to make sure you get chat somewhere you can see it because it tends to go behind the screen that's being presented.
Okay, good to know.
Yep.
Can I begin sharing?
Yeah, of course. You guys can go ahead and get started. I'm gonna go check on the other workshops, but I hope you guys enjoy the presentation.
Okay. Without further ado, I'm just gonna try to make sure I can see chat. Okay, can you guys see my screen? Just can somebody answer in chat? Perfect. All right, so before I formally begin the presentation, I just wanted to kind of share this. This usually is the front page of the New York Times, at least the website, because of the presidential election right now. It's taken up by a different map, but ordinarily this is what would greet you, and this is a visualization of um, current, I guess you could say, COVID activity in the United States. And while the New York Times paid some company tens of thousands of dollars to make this and run this web app on their website, uh, I'll say to you that we can make something pretty similar to this in under an hour in the time frame of this workshop. And well, really, that's the goal. So without further ado, hello, everyone. My name is Garrett Sullivan. I'm a senior here at the Pennsylvania State University. I'm majoring in computer engineering. Actually, I graduate in December. And today I'm going to be giving you just a brief introduction to data visualization in Python. And really, my goal for today is to show you how easy the libraries in Python make data visualization and how you can build something pretty robust in not a lot of time. Okay, so a brief outline of the presentation. First, I'm just going to cover kind of generally what is data visualization. Um, Next, I'm going to be covering the tools that I had you install earlier. Then we're going to sort of cover just getting started, setting up the Jupyter notebook for actually working. And then we're going to be going over a live demo, and you can follow along with me as I program our data visualization. So just some general assumptions. This workshop assumes that you're familiar with Python or at least object-oriented programming. If you're not, don't worry, though you may have some difficulty following along. Next, if you're going to be following along with me during the coding portion of this presentation, uh, you kind of need to have the software already installed. Particularly Anaconda can take a while to install. Um, and we don't have a ton of time today, so yeah. Oh, shoot. And finally, I'm using Windows, and I didn't have enough time to really test this out on a Macintosh computer. Um, so generally, this workshop assumes you're also using Windows. If any Mac users, or if any of you are using Macs and you run into issues, please let me know and I can do my best to assist you. Well, so what exactly do I mean by data visualization? And well, really, it's pretty straightforward. It's in the name. We are taking some data set on a computer, like say a database, or in this case, COVID statistics, and we are putting them into a form that makes it easy for humans to draw conclusions and see exactly what's going on. One of my personal favorite examples of data visualization is this. So this is basically a 1D graph of the number of unique words that various hip hop artists used within their first 35,000 words. And you can see, if you actually go to this website, it's highly interactive. You can hover over different hip hop artists. Oh gosh. Can you see the presentation? Like the slides?
No, on my screen as well. It's just the title slide.
Oh gosh, my apologies. It opened this in a new window. I didn't realize that. Let me attempt to change which one I'm sharing. Okay, can you guys see this now? Oop. Perfect. Thank you very much for bringing that up to bringing that to my attention. Okay, so back to what I was saying. This is actually just one of my personal favorite examples. It's kind of a fun example, and it's interactive too, in that you can hover over each artist. You can see here, I took a screenshot, I hovered over Snoop Dogg, and it'll show you exactly how many words they used. And you can see it covers a wide array of data, Snoop Dogg, Kanye West, Eminem, the Beastie Boys, and then way on the right is Aesop Rock. And one of the frequent criticisms of him is that he is very verbose. So moving along, So these are basically the 5 tools we're going to be using today for data visualization. I'm going to talk a little bit about them on the next slides, starting with Python. So why are we using Python? Well, first, it has a lot of open source or at least free libraries you can use for data visualization. It makes data visualization very easy. Next, it has very straightforward syntax. I mean, if you've used Python before, you probably know that. Um, Oftentimes I hear Python getting compared to pseudocode, and while it's not quite that straightforward, it's pretty close. So why Plotly? The first reason is that Plotly enables us to do fast and easy conversion of data sets to figures. I ripped this example from Plotly's homepage, and if you go to their website, you can see this. Seeing something new in chat. Oh, I guess not. So this particular example, it's an interactive stock graph, is less than 15 lines of code, which is kind of insane to me. The other thing is it supports a huge variety of figures. So today we're going to be making a graph called a choropleth, and you can see, I believe this was the results of some election. Again, not many lines of code to make this. And finally, there's built-in graph interaction. So actually, by default, Plotly graphs are interactive. If you don't want the user to be able to interact with them, you have to disable that. So again, just all of this comes right out of the box, very easy to use, which is why I like it. So why Jupyter? Jupyter notebooks are very widely used in the data science community. It enables running Julia, Python, and R, and that's kind of why it's so widely used. For those that don't know, Julia is basically a high-performance computing language. I believe it enables a lot of parallelism, which makes it very useful if you have to process large data sets. R, I'm not too familiar with, though I understand it is also very widely used in data science and statistics. So you can imagine being able to run all of these together in sort of the same window is incredibly beneficial. So why pandas? Very simply, we need to be able to process and access data very quickly. Pandas is a Python library that basically gives you a database-like data structure that enables you to perform, all of the wide-ranging operations that you would expect from a database. Why Anaconda? Anaconda is just a Python distribution, but it comes with its own package manager. So the people at the organization that make Anaconda just curate a library of Python, or curate a repository of Python libraries, essentially. And a lot of organizations like to use or prefer to use Anaconda for that because it keeps everything nice and organized compared to something like pip. Okay, so we're about ready to get started here. The first thing is, again, I kind of assumed you had installed or had downloaded the data ahead of time. This is a very small download, though, if you want to go ahead and grab it. The link is right here. It's also on the Hack PSU website. This particular data set is nice. It's updated daily around 6 p.m. And it is, I believe it's maintained by Atlantic Magazine, and it's so, I guess, accurate, or, it's considered to be a good data set because, medical institutions like Johns Hopkins use it, which is why I like it. Yep. Okay, so once you have the data set downloaded, you're going to want to drag it to your user directory. So on Windows, this is c/users/your name, because when you start a Jupyter notebook by default, that's the directory it starts from. Obviously, if you're doing, say, more in-depth development, you may want to make a repository from it. And then once you start the Anaconda prompt, you would then move into the location where you want to start the notebook. Okay, so how to start your Jupyter notebook, in case you haven't done so already. You'll want to search Anaconda in your computer search bar, and you'll want to open the Anaconda prompt. That's what should come up. And from this prompt, you'll want to type Jupyter notebook and hit enter. I'll give everyone a second to do that. Mac. That's a good question. Let me try Googling that real quick. Yeah, unfortunately, I don't have a Macintosh and I don't have access to one. So my guess is if you have the Anaconda prompt, if you start, oh, wait, no, because Mac has a Linux command line. You should be able to try typing Jupyter Notebook into the into the Mac command line and see if that does anything. Renu, did that work for you? Okay. Give me a moment here. So it says on the on just a guide I pulled up, you may have to CD into some starting directory from the Mac OS terminal, but you should be able to type Jupyter Notebook and that should launch the app. If needed, we might be able to like share screen or do something like that. I don't know. Is that Anish? Is that an option?
I think I might be able to link like a guide for Anaconda when installing for Mac in the chat if that solves this issue.
Yeah, I would. I mean, it sounds like he already has it installed, but it might just be starting up Anaconda. I do have to kind of keep the presentation moving, but yeah, Anish, if you could maybe paste a link to something in chat, I would appreciate that.
Absolutely.
Okay. So carrying on, you should be greeted like a screen like this in Windows. So the cool thing about Jupyter is it's actually running basically a web server on your computer. It runs, you can see off of, at least on Windows, port 8888. And it shows you the file structure of the directory it starts up in. So you can see I already have a few notebooks in my home directory just from other things I've done. And yeah, to actually create a new notebook, you're going to click on the new, this little drop-down menu and select Python 3. And you should be greeted by this. So what this has done is it's made a new Jupyter notebook, which is in the past it was considered IPython. Actually, I think it's still considered an IPython file. And you're greeted by, or you'll be greeted by this sort of development window. And if everyone's gotten to that step, we can move on to the live demo. Oh, perfect, Renu. Glad to hear that. And so these are the things we're going to probably accomplish today. We'll try. First, we need to actually load the data. Then we're going to try to actually display the data. And finally, the data, if we can only look at one particular piece of data, it doesn't really help us. So we're going to try to enable the user to look at other pieces of data as well. So I'm going to switch over to my main window where I already have Jupyter up and running. And I'm going to create a new blank notebook. And yeah, so if you've ever worked in Python, this is basically just a development environment, or well, really any language. This is basically just a development environment. And Jupyter, the interesting thing about it is everything is contained in a cell, and each cell can, I believe, be in exactly one language. So this could be a Python cell, and in the next cell, we could have, say, a Jupyter one. And like what really makes Jupyter stand out, or I said Jupyter, the next cell could be, say, a Julia one. But what makes Jupyter really stand out is you can take variables from, say, your Python cell and then manipulate them in a Julia cell and then transfer it back to Python for ease of access, which is, and you can see kind of why that would make it so popular in data science. So moving right along here. So the first thing we need to do is make some imports. I kind of know off the top of my head which ones we need. So the first core part of this is Dash. Dash is actually going to make, it's sort of going to run a web server that's going to display all of our graphs. Then we're going to do so this Dash core components library just contains a lot of sort of essential functions for Dash. And then we want, actually this might not be, we might not get around to using this today. Excuse me, having some trouble typing. But basically, so Dash runs, if any of you have ever done web development in Python, Dash runs Flask under the hood. And you can format that, you can format the, excuse me, I got a Discord notification, got to shut that off. But you can format Flask using, or format the web page in general just using sort of these Dash HTML components. And we'll want to import that as HTML. And finally, we're going to import these two things. These are going to come in handy later, and you'll see why, but basically input and output enable us to manipulate things that are currently running on the Dash app in real time. So if, say, for example, we have a graph that is, if we have a graph that has some data set associated with it, and we want the user to be able to select a different data set to display, input and output will enable us to do that. But we'll get to that later. All right, so I like to comment my code just so people generally know what's going on. We're just going to consider these Dash components. And the next thing we'll need is graph components. This is really at the heart of what we're doing today, because you can run Plotly without running Dash, but Dash makes it very easy to format things. So the first thing we're going to want to do is import Plotly graph objects. And basically, this is a graph object the class behind this is what actually enables you to graph things. And it gives you a wide array of different graph types, and each one of these have certain parameters in common that make it very easy to manipulate the graph exactly how you want it. So Plotly Express, I'm not sure if we're going to need to use this today. It's just generally a good one to import. Basically, it gives you some lighter weight graphing options. Say if you don't need to use all of the features from graph objects, you can just use a Plotly Express one instead. And that can be better for like run times and that kind of thing. Also, I should mention, or I forget if I mentioned this earlier, but Plotly makes Dash. So basically these two groups of libraries interface very well together. So moving on, and finally, the last thing we're gonna need to do is import pandas. And that's just, again, gonna enable us to manipulate the data very easily. So the very first thing we need to do here is we need to instantiate a Dash app. And by the way, I'm sorry if there's background noise. My apartment has very thin walls. And so what this does is this basically starts up, or once we actually run this, this will start up a Dash web server on an HTTP address and on like one of the ports on your computer. And by default, that port should be, your firewall will block any outside traffic from coming in on that port, though you can, if you wanted to, set this up so that other people can access it. Wouldn't recommend that unless you know how to securely do that, but it's possible. So actually, I guess one thing I wanted to do before we go any further is actually take a look at our data set. And I just need to open up a file to do that. One moment. Actually, let's just open up okay, if we go to Google Sheets and open up a blank workbook, you don't need to do this. I'm just doing it for the sake of visualization, just so we can get a better idea of the data set we're working with here. We can do import and upload. Then if we go to that data set that we downloaded earlier, oh, should have worked. Let's hope this imports properly. Perfect. Okay, so this is the data set we're going to be dealing with today. And you can see it's organized by date, and this specifically covers the United States, just because this was the only one, this was the data set I was familiar with. If you wanted to get a worldwide data set, I have no doubts that one is out there. But just for the sake of today's presentation, we're just going to be going over the United States. But you can see it organizes the data by date and then also by state. And these are all of the parameters or all of the values we're dealing with. So you can see it covers total deaths. It also covers the quality of the data, which can be useful if, say you were if you wanted to, well, just inform your user if a data set might be faulty. But yeah, then it covers confirmed deaths, hospitalizations, just anything you could want to know about the virus in the United States. So moving back to our notebook, the first thing we're going to want to do is import that data as a data frame. So on my computer, this data is sitting in a CSV file in the same directory that this notebook is running in. So what we can do is do something like this. Usually the default name for a pandas data frame, you just want to do df. And we'll do pd dot read underscore CSV, because I downloaded the data as a CSV file. If you downloaded it as, say, a JSON file, excuse me, I believe there is a read JSON, but today we'll be working with CSV. And we'll want to take the name of our data and simply copy it in as a string. And just to confirm that that's running, I'm just going to go ahead and print it out. And so to run your Jupyter notebook, what you'll do is you'll just highlight the cell that you want to run, and it will execute this cell and any cells below it. So we're just going to hit run. Oh, and already we have an error. Oh, geez. That should run. Yeah. Or not. Well, as I said, we likely won't be using these anyways, so I'm just going to comment that out for now. I'll have to look into that later because I know I have that library installed. Okay, this is just getting weird now. Error was Python import. This is unusual because I know for a fact that this syntax, I've written this module out ahead of time to make sure everything worked properly, and I know this is the syntax I used. I might need to go and check on. Just to make, I might need to double check that that is correct. It should be though. Give me a moment. Thank you, Michael, or Michelle. So I'm going to start up another Anaconda. Worst case scenario, like I said, I have this file fully completed. I can just show that, but I would like to figure out why people are running into, well, including me, why I'm running into library issues. It's a bit unusual.
Is it possible that if you like updated Anaconda that you have to like reinstall all the libraries as well? Or did you already sort that out?
I mean, that's a possibility, but I haven't updated Anaconda on this machine. I was trying to get it updated on my laptop so I could present from my laptop, but yeah, if I run the Jupyter notebook from here. Oh, and this will, okay. I'm going to drag this into a separate window. Okay. Oh, wait, is it that simple? No. Okay, Renu, glad to hear yours is working without error. I just wish I could figure out why mine's not. Unless I just misspelled something. Well, let me just copy paste from things I wrote earlier. That's the thing, like it should be running exactly. Oh, wait. Oh, and now it's running fine. Okay, well, carrying on then. You can see that, I mean, this is a very messy printout, but you can see that it printed out our data, so at least we know that it's there. We can comment that out for now. That was mostly just a sanity check. But moving on, so the next thing is the data should already be sorted by date, but just to be sure of that, we can do something like df sorted. Let's just do, I think it's sort by, or is it sort value? I think it's sort values. And then by, it's the parameter is equal by, and then we put the field that we want to sort. So date is one of the name of one of the columns. So this will sort our data set by date, or at least ensure that it's sorted by date. And if we run this again, nothing should happen. That was expected. At least nothing's bad. Nothing bad is happening anymore. Okay, so that, I'm sorry, the last thing we want to do here, I just remembered is, so the way this data set works is it's cumulative, just this particular data set. So the number of deaths, for example, is the cumulative number of deaths over the entire course of the pandemic, starting all the way back in January. So we'd rather the most useful thing would just be to look at what the data looks like today. So we could create something like a variable like data frame today, and we need to just fetch the values from today. And Pandas has this neat little method that's just called locate. And locate is super, super flexible. Basically, you can enter column names. I believe you can enter rows, and it will kind of sort things out on its end to get you the data that you want. So going to do locate, and then we want to locate things by the most recent date. So rather than like hard coding a date, what we can do is actually just index the very first date, or the first date on the first column. So we can do date equals okay, and as another sanity check, we're going to print, if I can type, we're going to print df today, just to make sure it's only fetching the values from today. Actually, that might just give us today's date. I forget exactly what this will do, but that's why we can run it. Oh, no, perfect. So yeah, so you can see this has just fetched all of the data. Well, not from today. So the most recent data is from yesterday. So that's what it's given us here. And you can see this is just the first 55 columns. So there are, I believe, 55 US states and territories represented in this. And that's what it's given us. So that's operating correctly. Module. No module named dash core components. Try rerunning it. If needed, so an interesting thing you can do is you can interrupt the kernel, like the Python kernel, or you can restart it and then hit run again. Sometimes that fixes things. Also, I mean, if you have Dash installed, you should have that library installed. Again, that's just one of the general libraries I usually install. I'm not 100% certain we're going to be using it today. Rena, let me know if restarting it worked. Okay. Yeah, just keep me posted. So moving right along, so basically Plotly works based off of defining figures and then giving those figures data or graphs or plots or whatever. And then we pass those figures along to Dash, and Dash will display those on a web page. So we're going to go ahead and define our first figure, or well, really our only figure. We're just going to have one map today. And it'll be graph object dot figure. And so this gets into one of the reasons why I sometimes don't like Plotly is there are a massive number of parameters for any given thing, which can be very helpful. It gives you a lot of flexibility. But a lot of those parameters end up being massive dictionaries or lists, and it can get a little bit confusing in terms of like matching up all of the brackets and braces. So that is something you have to keep in mind. And in some cases, it can actually be worth violating, say, Python styling guides to just make your variables or your parameters a little more organized. Just sort of a helpful tip. So the data for this figure is going to be a graph object called a choropleth rather. And a choropleth is just simply a map graph. Like in our case, we're going to be using US states, but which is one of the two maps that Plotly comes with by default. But you could use any map, really. You could use Mars if you really wanted to. So the next part is the choropleth in particular has a parameter called Z. And Z is, so the choropleth is a map. The Z is basically the intensity of each cell on your map. So in our case, the cells are going to be states, and Z determines how intense they're going to be. And in our case, by default, we're going to, let's do death by default. A little bit morbid, but it is unfortunately relevant. And so basically, the higher the death count in this case, the more intense the color on the graph will be. Next, we're going to do locations. So locations, this will map our data set to the map of the United States. Basically, I believe it looks for matches in the, I believe it looks for matches in terms of the state name and the states that it has on the map. So locations, it'll be DF today and states. So that should map the states to their proper location on the map. Location mode. So again, by default, Plotly comes with two locations, a world map and a US map. If you wanted to use, say, a map of another country, you would have to get the GeoJSON or a GeoJSON file for that country. They're pretty widely available online. Some Googling will usually turn up a pretty decent one. But in our case, we can do USA-states, and that should give us a map of the United States. And I believe we need something like auto color scale. So what that should do, and that's just a Boolean, so we can set it to true. I believe that will automatically adjust the color scale to the incoming data set. Okay, and the next thing we need to do, okay, ooh, we need to hurry this up. We don't have too much time left. We need to make the layout of our application. And oh, actually, we definitely do need the dash HTML components. So you can run that graph by itself in the app, and that would look fine, but making an app layout with HTML gives you control over how exactly your web app is, or how exactly your web app looks. And I think it's worth going over. So, excuse me, it's going to be html.div. And for those of you that are familiar with HTML, this is identical to a divider in HTML. So first thing we should do is probably give our web page a title. And we can just name it something like HackPSU COVID dashboard US. Oh, that should be fine. Then, so in addition to, so the graph object, the go.figure generates like a graph object figure. In order to actually get that on our dashboard, we need to do dash core components.graph. And that basically, again, Dash and Plotly made by the same company, they work really well together. And that'll basically let our dashboard know that it needs to graph this thing. And we'll need to give it an ID because we only have one graph. I think main graph is appropriate. And then figure, we're just going to set that equal to figure. So this sets figure the parameter equal to figure our global variable or our global object. And general, it's a good idea, even if it's the last item, to end it with a comma, because a lot of times in Dash, you'll be adding other items to, or other parameters to this as your web app grows in complexity. So just helps avoid dumb errors, I guess. And yeah, actually that should be enough to actually get the app up and running. So finally, we're gonna do, this is a Python convention. And it's if name is equal to main. And what this does is basically when you run the file, you don't need to make any kind of calls to anything. It will just run whatever is within this if conditional by default. And the command to actually run your Dash app is app.runServer. Again, so Jupyter is operating in a web server, but once we start this Dash application, it will start its own web server, and that should also pop up in your browser of choice. Okay. If we hit run, and of course, more errors. Give me a moment here. Here. State.
There is one. Yeah, there is one that I spotted. In line 28, location mode, it's USE.
Ah, good eye. Thank you. Okay. If we save that, rerun. Ah, perfect. So you can see it starts running the Dash app at this address on this port of on our computer. Again, by default, your firewall should block outside activity from coming in. Though if you were actually deploying this, obviously, like on a website, you would want that activity. And if we open it in a new tab, you can see our browser just sent HTTP requests to the server, and it'll display those here, which I think is pretty cool. And if you go here, you can see if we zoom into the US, this is currently displaying again, somewhat morbidly, total COVID deaths by US state. And you can see the scale here on the right, 0 to 25,000. New York has been hit fairly hard, so it's at the top. And as you can see, a lot of these states haven't been affected too much yet, though I know it is currently rising. Well, actually, that brings me kind of to my next point. I know for a fact it's currently rising quite a bit in the Midwest. Oh, Renu. Invalid syntax. That's one thing, that's another thing I don't like about Dash is its errors can be very ambiguous. Oh, Renu, is that a circle bracket or is that a parenthesis or a like a, it looks like you might have the wrong kind of bracket on figure. It should be like one of these and not like one of those. Let me know if that fixes it. But anyways, as I was saying, I know for a fact in the Midwest, cases are unfortunately on the rise, and we want our user to be able to see that. In fact, that's a specific part of this is hospitalization increases, death increases. And that's data we'd like the user to be able to see. So how exactly do we do that? And I'll just stop the web server. So we can do that. If you recall, I mentioned these input-output functions. These two guys will allow us to actually update the data in the graph. So the first thing we need to do, oh, and another point about the last map, you probably saw it was a world map, but the US was the only thing in color. If we wanted to focus just on the US map, what we can do is update the figure layout. So we do a figure dot update layout. And actually, let's give our figure a title. In our case, this will, again, by default display deaths. So we can do deaths, excuse me. And then we do geoscope. Excuse me again, oof. And we can just set this to USA. And now this will basically zoom in from the entire world just on the United States. And it'll just make it a little bit easier for the user to visualize just the data we have, or the area we have data for. Just to make sure that worked, I am going to rerun this. And as you can see, it's just now displaying the US. So I'll stop it again. So in order to allow our user to select different kinds of data, we need another Dash core component called a dropdown. And this will give the user, this will display a drop-down menu. And again, we're going to want to give this an ID. So we'll do ID equals, let's just call it something like data select. And in terms of options, so for those of you familiar with Python, you might have used a generator object. Because we don't want to hard code the stuff we have in our data set, because it could change, they could add new fields, particularly if you were indexing this data as opposed to just having one static data set. If you made like an API call to the website, that could change. So what we do is, and the way the options work is each item in the drop-down table is actually just a 2-item dictionary. And each item in that dictionary is label. And I'm going to use call as my generator word. And the other item is value. And we're going to make for each item in our table or in our database, we want to generate one of these dictionary items in the list. So we do for call in df dot columns, if I can type, dot columns dot values. So again, the cool thing about data frames, you can just tell it, hey, get me the values for just the top values of the columns. And if we go back to this, we don't want these first three. These aren't the actual data. They're just kind of, well, they're not the data itself that we're going to want to plot on the map. We just want from this onwards. So we do something like, I believe that was the 0, 1, 2, third index. So we do 3 onwards. And so what this will do is it'll rip the value of each column from 3 onwards. And then the reason we're doing the label, well, you'll see why the label is going to be equal to the value. In most cases, that wouldn't be the case, but again, you'll see why. So we need to define an update function. And I'm going to try to finish this. We only have 6 minutes left. And so basically, this function in the end will update this figure, or specifically it'll update whatever this graph is using as its figure. And so we're actually going to just take this, paste it in there. There's probably a better way of doing that, just like a more efficient way, I should say. For the time being, this works. Let's see, we've taken that figure data equals that. Yeah. And rather than using def, we're going to change that to value. And then we're going to do a figure update. So this won't update this figure, it's going to update the local figure in this function. Actually, geoscope doesn't need to change past the original one, but we're going to retitle our graph as whatever value was selected by the user. And then we're going to return figure. Now, the function's implemented. However, how do we actually get this graph object to update to this new data set? Actually, let me indent that just for the sake of clarity. Well, we can do that with a Python decorator. Now we can do it's in Dash. It's specifically an app.callback. And this is where we're going to use our output. And the output takes 2 arguments. First, it takes the ID of the object you want to modify. In this case, it's going to be main graph. Then it takes the field within that object that you want to modify. In this case, we want to use figure. And because figure is just one of the normal parameters, Dash will see this, or the app will see this and know that it needs to update this parameter. Then we're going to do, and because you can only have one output with this, but you can have multiple inputs. So your inputs actually go in a list. In our case, we just have the one input. So data select, so the ID of our dropdown. And then what do we want from that dropdown? We want the value. Realistically, we could also use the label for this, or say we wanted to pass the data directly from the database. We could just grab the values from that database here and then just pass them along that way here. But this way also works. Okay, I think all that's lined up. And this should allow us to now update the data. So let me just make sure the kernel is stopped. Rerun. You can see it's running on the server. And ooh, that's not good. Key error none. It might be running into an issue. That is sometimes the, again, sometimes it can be, so you can see this did pop up. Actually, no, you can see it is functioning. I think it's just, Oh, wait, we did need the USA update. So this actually, in spite of the error we got, this might just be some kind of a, I don't know, something that Dash is upset about, but doesn't actually impact the actually running the program. We do actually need to make sure we maintain geoscope on this. So if we stop the kernel again, one last time, and run this, make sure we're running the right cell. Sometimes it takes a second. Yep. So if we go here, again, it's upset about something, but you can see that, yeah, we have the, now our graph updates to whatever we're selecting. So again, this is a little bit grim. Unfortunately, cases in the US are going through a major rise right now, but you can see not all states confirm deaths, so that's why we don't have data for every state. But you can see the death increases. Actually, hospitalized increase would probably be a better statistic. It's starting to increase a lot in the particularly this central United States right now. I think that about concludes my presentation. I think I have one final slide here. So thank you all very much for attending. And if any of you have any questions about this, I'm not a master at data visualization, but I'm pretty decent at it, and I'm also pretty decent at Python. Feel free to send me an email. This is from an old slide. It's not intro to Python. It's just intro to data viz or data viz workshop. Again, thank you all very much for attending. I hope you got something useful out of this, and happy hacking. All right, I think that's about it.